thank you all for coming, also for sticking around for the second session. So we'll try to be as efficient as possible. We do have a lot of ground to cover, so let's get started. Just a brief glimpse of the agenda. We'll talk about just what Studio and Studio Map SDK are, and Ranshin already covered some of the details about the Studio offering and Foursquare offering, so you might be familiar with some of those. And then we'll also try to uncover one problem that we discovered while working on the Map SDK and kind of iterating on its API. And we'll try to understand what the core issue might be, and then try to see how it also applies not just to software engineering, but also to many other things and topics in general. Then we'll try to come up with a solution and see how well it can work, and then just some final strategies for maintaining libraries, because they do have a completely different set of considerations there. Just a few words about me. I'm a software engineer here at Foursquare, working at the Studio team, and we'll just briefly talk about it. But also I wanted to learn more about you, the audience. So with a quick show of hands, if you can tell me just how many data scientists are here. Alrighty, so we have like 7, 8 people. Do we have any product people? Okay, thank you. 1, 2 people. Do we have any design people? None? Okay, half of a person. And and do we have engineers here? Alrighty, huge majority. Alrighty, thank you so much. Let's cover like what Studio is, and as you heard Ranshin as well, Foursquare is nowadays not just a mobile app, but it's offering a lot of different products, and it ranges from data and different ingestion and packages with it, but also gets to the data visualization. And visualization is actually a very important step in the pipeline because it allows all the non-engineering personnel as well, people like sales and marketing, to draw the insights from different kinds of visualizations. And Studio, as I colloquially say, is basically a Photoshop for maps. Basically, you input your data, then you create different visualization layers, and then draw conclusions from it. And just briefly, here's a kind of technical summary of the underlying technology. And it's mostly powered by open source libraries maintained by some of the biggest companies in the world. So we have definitely Foursquare, we have Uber, Joby Aviation, Amazon, all the big name companies are there helping maintain open source libraries. Probably kind of the highlight of the libraries is DeckGL and KeplerGL, which are under the hood powered by additional libraries such as LumaGL, and I'm missing something there. And DeckGL is a library that uses GPU to render everything very efficiently on your computer locally. And it comes with support for many different visualization formats for input, but also visualization styles as an output. So hex styles, raster, heatmap layers, all of that is supported really to kind of help you just display the data in a way that best suits you. Studio is basically this very complicated offering around the visualization library that allows you also to kind of collaborate with your team, store data in the cloud, authenticate everything safely. We support even more additional data formats and visualization types. And there's a huge number of customization options, additional transformation, data joins that you can do, expressions, all these kind of things that basically allow you to open a studio, put some data, ingest it, and then visualize it. Foursquare Studio is not the single offering. It actually kind of comes on the side with an entire data catalog that we at Foursquare are maintaining with the help of some friends. And a bunch of this data is completely freely available. So if you actually go to the website, you can find various sorts of data to get you started and actually test the Studio. Studio is completely free to start using it. There are definitely premium features, but you can kind of give it a shot and see what's there to offer by either using these very like well-constructed and maintained data catalogs, or you can also rely on some of the community-made maps. We do have a lot of users, and they also tend to make public maps, or actually just publish maps with a certain snapshot in time. And again, these are also free to discover, so definitely check it out. Just recently, a use case that we had was on the right side, visualization of the earthquakes in Turkey this year. And also on the left side, we helped people visualize fires in Hawaii. So really disaster relief efforts are also there as kind of use cases. But also on the enterprise side, we are helping big businesses make very important decisions. The programmatic way to go about creating studio maps is actually in the offering that we call Studio Map SDK. And this is basically a library which is either a TypeScript flavor or Python flavor that you can use to then, through code, programmatically create maps that you can then store in the cloud. Or if you don't want to expose any kind of data and have privacy concerns, then you can actually visualize all of that data completely locally, store everything just in memory, visualize it with this GPU-powered open source libraries, get some insights from it, and then move on from there. We do have a couple of different versions. The public version that is completely free and available and really does come, it includes many of the features that are available in Studio, and actually Studio and SDK do share a lot of the features. So what you see in Studio is probably what you can get in SDK as well. We do integrate with some other very popular geospatial software such as QGIS and also Grafana for visualizations. When it comes to Python flavor, most common case that people use it is something like data scientists, data engineers doing some sort of data transformation and ingestion in Python computational environments and Python notebooks. And for that, we also support the different environments such as Colab, Jupyter Lab Notebook, also Amazon SageMaker, Databricks. So really, there's a lot of different ways how you can go about it and can satisfy the needs of like very different customer profiles, whether it be engineers or somewhere in between for data scientists, or just like for somebody looking to get some insights like sales and marketing. Map SDK, just to give a glimpse, is like how it looks like to use it. You can actually create a map in just like a few lines of code. This will like create an empty map, but also in this example, on the left bottom, you can also like use our support for data frames and then very easily put the data into the map that gets visualized. And again, what you're seeing here is a Python flavor of the SDK, and it's not really anything super uncommon compared to all the other libraries that are being used in computational environments. Also, we do support displaying full studio-made maps. So again, with just a few lines of code, in this case, again, 3 lines of code, if you have a published map, you can display it in your, for example, Jupyter Notebook very easily. So we work very hard at kind of enabling this kind of very good and easy, streamlined developer experience. But not everything is great, and that will be the main point. But also to kind of give this a wrap on kind of use cases that SDK can be found for. We do have a lot of customers that are doing fully programmatic and automated pipelines. So basically, they have data somewhere in the cloud, and maybe they are using either studio-provided connectors and through our other SDK offerings, such as Data SDK, to get then pull that data, create maps with Map SDK, visualize it, create all the output, generate reports from it, and all of that happens completely automated fashion, likely running as some cron job or being triggered by some action. So very complicated, complete end-to-end workflows can be achieved purely programmatically without any interaction from the user. And a lot of our users and kind of premium customers are using this, and in good chunk of cases using this to generate reports that kind of output things daily and give them insights like everyday fresh data to draw conclusions from. So as I mentioned, like everything seems great, and I will cover like what we have in Map SDK and like how it looks like. So We, again, did spend quite a bit of time working on this and trying to kind of make it very useful and easy to use. We put a lot of effort in kind of on the Python side, providing all the type hints, providing all the inline comments and documentation. We also use pedantic validation schemas. So everything is very tight. We cover everything with tests. And from the looks of it, everything should be great. And for most of our users, the experience really is great. So they, in their computational environments, they get all the autocomplete, as you can see, and also the inline comments are there. They can jump to various definitions, get very concrete information about the type of data and data structures that they're dealing with, and everything seems great. However, not all of our users get that great experience. And depending on the environment in which they're running our SDK, they don't get all of the benefits. And despite our best efforts, all these kind of additional type hints actually end up being just opaque types. And they are completely not transparent to the users. They don't know how to go about it. They lose all of the additional autocomplete, all the documentation is gone. And that means that they have to actually kind of go back and forth between the documentation and their code editor, which ends up being a very painful experience overall. And we didn't want to leave our users at this. So like we really wanted to improve. We didn't want to change our users. We wanted to make experience better for them. So we wanted to understand like, okay, like what's going wrong? How can we improve things, and how it could have happened that we overlooked anything? Did we overlook, or something else is actually driving this kind of poor experience for our users? And kind of looking at this very abstract version of the pieces that are communicating here, we do have users on the left side and Map SDK on the right side. And looking at the Map SDK, we are seeing that, okay, all the interfaces that we are exposing to the user seem completely solid. Everything is covered with type hints. The experience should be great. We do have inline comments. We do have documentation. So the external interfaces should be there in place. Also on the internal implementation side, we don't do anything crazy, but also everything is very well documented. The code is well structured. So we should also be good there on that side. So if we are good on the right side where our Map SDK is, and on the left side we have users, and we can't really change nor want to change anything about users, then like what could be going wrong? What are we missing here? And now in retrospect, a lot of things are obvious, right? And basically the only remaining piece on this diagram is the thing in the middle. So how the two things communicate is actually what probably is causing some of the issues. And that something is actually the environment, or like the channel, how the two things communicate. And as we kind of try to understand, like, where is this again coming from? We got actually reminded from a very famous diagram in theory of communication. And again, here is a bit of simplified version of it. But also there, kind of the standard, most basic diagram that you see is how two different systems communicate. And a lot of actual focus is spent on the channel or the medium for the communication. And in theory of communication, it is well known how the channel can introduce a lot of noise and how it can actually degrade the signal and in some way modify it. But here we actually aren't experiencing like degradation in communication, like our SDK and our users, like there's no really loss of information. It's more about how the channel between them actually alters the semantics of the communication. We provide types, but our users don't end up seeing those types, like they don't get all the benefits. So some information in there, some semantics is lost. But also, like looking at this diagram, we can also try to like give other examples and just see how the environment actually can affect different things. And like this, perhaps like even a silly example, but if we have two people that are trying to communicate, just like talk to each other, and they are in an environment, they can still see each other and kind of estimate each other's facial expressions and body language. Everything is normal. However, if you put the same two people in two separate rooms, the situation, like the environment has changed, and the situation how the two people actually communicate also needs to change. It is very likely that now these two people will have to yell. And if they're yelling, now there's a super interesting problem. Are they yelling because they are angry? Or are they yelling because they just want to be heard from the other room? Or maybe it's both. Maybe they are yelling because they are extremely angry and want to be heard. So the semantics of the communication has changed. Even though the two components in this system, like two people, nothing about them has changed. So the capabilities of both person being able to speak and communicate is not altered, but still the way and style of communication is. And this was like very curious finding. And we'll say like an example that we are probably all familiar with is when we actually started working from home when COVID started. So again, with the exact same organizations that we were part of before the COVID, nothing about it has changed. It's all the same people, all the same colleagues. We are all the same. Yet now we are all working from home, and our communication style, the way the processes are handled, is different. So usually things suffer, but in general, like things are changed. And organization really has this kind of like it should try to make things as easy as possible and to clear up any misunderstandings. And so it's up to organization to really design the environment in a way that it really makes it obvious what is being tried to communicate. And again, different organizations structure these things differently. Some will call their workers to kind of visit in office once in a while, or maybe never. And all of that affects just the general communication style, even though, again, the components, us people in the organization, nothing about it has changed. And again, moving this back into the world of IT, we actually think about this very often. People on the back end, when they think about the communication between the services or microservices, do you think about how the what's the protocol for communication between different services, how they actually discover each other, what's actually coordinating them. And all of those things are, again, impacted by the kind of environment in. And what's actually interesting also in the case of microservices is that we always kind of, please don't burn me for this, choose between the kind of oh my God, the microservice architecture or the application where everything is in one instance. And basically what we're deciding in how the different parts of the subsystem are communicating and where we are actually making the trade-offs. So all the discussion is happening on the side of, well, which environment are we choosing and what kind of trade-offs are we making there? So this pattern is present, as we saw, not just in IT. It can also impact the communication between the people, but it also does impact pretty much everything in IT. And we do have a lot more examples how the environment impacts our decisions and like the capabilities. And a very common case that is probably familiar to all of us is how when we are designing an application for mobile, it's a different set of constraints compared to designing for desktop. And the capabilities, we would like them to be the same. What you can achieve on a desktop machine, you should probably be able to achieve on a mobile phone. However, you still need to adjust a lot of the UI. And through that adjustments of the UI and considerations with the performance of mobile, you are still making some trade-offs. So you want to preserve all the capabilities, all the features that you have, but still the environment in which everything will be happening impacts also your implementation. And that's very interesting. And then in the extreme case that is kind of connected to that is, like we wanted to, when we were making phones for the first time, the kind of grand idea was, okay, we want to have the capabilities of a computer, but just like make it portable, make it available everywhere. Or like as you go, you should be able to access it. But then what happened is, okay, we're in an environment where we don't have power outlets everywhere. So what do we need to do to overcome that? Well, we need to probably have a battery of some sorts. Well, if we have a battery, then it probably like only has a limited amount of time before it kind of drains. If that's the case, we probably want to make our hardware, our chipset, very optimized so it drains battery slower. So now we started with just the desire to create something that behaves exactly the same as the computer, but now we are already making changes to the hardware. And once we made the changes to the hardware, we are also considering, hey, but we should also make a very optimized version of the software. We don't want to be running the same operating system with all the overhead on the desktop machines. So now we are also changing the software. But the software is also now exposing different APIs. So all the third-party libraries and apps that are being developed for the mobile are also being changed. So what ended up happening is we desired the same thing, yet the environment changed our hardware, software, and kind of third-party integrations. So all levels were impacted just because of the environment. And that was kind of perhaps the main conclusion on our end. Environment and capabilities do impact each other bidirectionally. So it's not that just the capabilities happen in an environment, but actually environment can really drastically shape the kind of features that then actually end up shaping the implementation as well. So now that we actually understand that kind of a problem a bit better, so what can we do for our case? We did everything on the implementation side, but how we can improve the experience. So we knew what our users are actually seeing. It's a hindered developer experience. And that put just an additional constraints on us and what their environments and their computational notebooks can offer. So just some additional trade-offs have to be made in how we are designing our API and then doing the internal implementation. So the things like relying more on the primitive types and data structures. So no deeply nested types or opaque data structures. We can't do that because they don't see any comments and don't have the documentation hints either. The code would ideally be self-documenting in a way. The code, as they're writing it, should kind of guide them to the correct solution. There should be no guessing and no ping-ponging between the documentation and their code editor. We want to streamline the experience and just make it pleasant. And again, it's supporting this in all the different environments. So we made definitely more than one iteration on the idea and a lot of internal brainstorming and also taking inspiration from other libraries. There were actually two kind of good contenders, and I want to kind of cover them so that maybe they also serve as an inspiration for your case. One of them being the composite pattern. This kind of pattern kind of lets you define very small objects that are then very flat and easy to define, can be reused in a lot of places. It's a pattern that is really common in general for all the languages, for all the different environments. And this seemed like a very good solution, very also easy to implement. But the thing actually that we didn't like is that because you're making these intermediate small types for all these small intermediate steps, it actually ends up expanding the API surface tremendously. What ends up happening is kind of consequences is that user is not anymore confused because they are lacking types. Now they're confused because they have way too many options. So knowing which one to pick, which one's the right one, which one should go in which place, which parameter exactly it is, where to finding, depending on how you nest these data structure definitions. It's a similar problem that we actually try to avoid. So this seemed like, okay, we're making a trade-off, but now just in a different place. So can we make it a bit better, perhaps? And the other thing that we really started very seriously considering and iterating on is the builder pattern. Again, it's not an uncommon pattern, and it's kind of pretty well known in some communities, more, in some less. But it's a pattern that allows you to basically progressively create objects. They start with some reasonable defaults, but then the API itself allows you to only do very specific set of operations that really guides you towards the correct solution. There is no way to go wrong about it, again, depending on the implementation details, but it kind of guides you, and because of it, you have full control of the API, and it is kind of self-documenting. You don't have to guess if something is possible. If it's provided as an API and as an autocomplete, which is thankfully supported in all of the environments at this level of implementation, then what you write is what you get, and it's correct. Like you won't be able to make a mistake. One downside that we saw is that it's a bit harder to implement, also depending how you go about it. But for our users, this presents like an incredibly good experience. And just to be very concrete, we actually shared this with our users and asked them for opinion and kind of try to also compare this kind of pattern with the experience that they had previously. And they were ecstatic about it. They were very excited, and they saw how many of the problems that they had before were solved. So this is a very likely candidate that we will be, in general, going with. Now that we kind of had the solution in our hands, we also wanted to see how we can go with the next steps. So how can we actually introduce these sort of changes that aren't really even trivial and kind of expand our library from what we have currently. And we were also trying to understand where the things can go wrong, and again, why they can go wrong. And one thing that we noticed is that there is a very different way how you interact with most apps and websites compared to how you interact with libraries. With websites and apps, basically every time that you open it on your mobile device, on a desktop, you get the latest version. So any change that happened in the meantime is probably deployed by that point in time and available to users immediately. So they always experience the latest version with all the new things and all things removed and all the fixes. But this is very different from how developers interact with libraries. With libraries, you actually rely on a certain dose of stability. So when you're using a library, you're probably installing it at a specific version, and you're expecting a specific API to be exposed at that version. And you're writing a lot of the business logic around it that kind of assumes that that API is stable and won't be suddenly changing under your feet or anything like that. So this kind of interaction cadence is very different and puts an additional and sometimes very difficult constraints to go around when dealing with libraries. So the things that we also had to think about is, okay, so however we are introducing changes, we should know that changes should happen rarely because they're very costly. Again, if you introduce breaking changes, the API changes in a way that breaks the previous assumptions. Whoever is the user of your library will need to re-implement a lot of the business logic around it. And this is costly for them, not just in time, but in actual money, resources that are necessary to upgrade all the pipelines, to get the developers, to align them with all the other teams. So it is a very risky and very costly thing to be doing. So there are definitely a couple of different strategies how you can go about it and kind of try to give a heads up to the users by using semantic versioning, so you can signify, hey, this is the level of changes that we are introducing. You can kind of prepare them also by using migration guides and preparation compatibility packages. And one thing that we are actually considering is using future modules. And that is basically extending an API with versions that are known to users that are kind of risky and will be changing. So you basically expose new things to the user, but let them know that the assumptions around that are at their risk and they should be aware of it. However, once this hits a stable version, it will be much easier to migrate because they probably already opted in and made a certain amount of changes. The other thing, again, besides kind of announcing the level of changes, is when you announce them. You really need to give users a lot of time to prepare for the changes. This is also ahead of time, but also when you're deprecating older things. And like in this example, this is on the left side is a timeline for different versions of the Node runtime, and on the right side is for the Python. And if you can see maybe these kind of vertical slices, They're basically in yearly quarters and years even. So for library maintainers, giving a heads up even in like period of several years is actually required. And this is, again, very different from how you develop apps and websites where you can just make changes, and the next time they visit the website and open an app, they'll just get the latest version, and they're very satisfied with it. So you need to be thinking ahead of time quite a lot. And as I mentioned, like the apps and websites can work very differently, and one of the most powerful and probably the most liked tools for any product manager is not available when you're dealing with libraries, and it's A/B testing. There is no A/B testing when dealing with libraries because, again, our users, the users that are using the libraries, depend on certain dose of stability. If you deliver A and B version or even more versions of the library with different APIs, and then in the very next version of the library, you break the promises and remove all of those options except one, you will also break a lot of hearts. So A/B testing is really not an option. And this makes it really difficult to kind of make quick iterations, kind of efficient iterations when maintaining libraries, because you can't make small choices and then test them out quickly. You really need to put a lot of thinking ahead of time. And how we at Foursquare are dealing with this is we are creating API audits where we internally discuss the possible API changes ahead of time and kind of try to estimate what kind of costs there might be. But we also talk with our users and try to get that feedback. And combining this with that approach of using future modules or future flags where you try to give the option for users to opt in into newer versions as soon as possible to also gather feedback becomes a very useful kind of feedback loop that allows both you and your users to iterate as quickly as possible, but still a bit slower than when working on apps. And the final thing is because the cadence of the interaction with libraries is very different categories of users are interacting with your app. The developer that implemented your library today might not be the same person that will actually try to upgrade or migrate your library sometime in the future. And they might come from very different backgrounds as well. So really trying to understand who the potential users of your library are and how to approach them, what is actually their use case, becomes very important. And I think a very good example is here how Remix does it is basically they give you a choice. Hey, are you a completely new user or you have some dose of familiarity? What exactly is it that you're looking for? This does come at a cost of having a lot more documentation to maintain, but still, as our desire is to really satisfy the users and give them a great experience, it is our responsibility to really try and do these things well. So a couple of things as kind of the key takeaways is just how environment really can impact all the pieces of the systems that we are considering. And these systems don't have to be even in IT and software engineering. They actually impact our everyday lives. And any company that you work at, you are actually thinking about that kind of problem. And just how deep that impact can go is something that we kind of rediscovered, and it seemed like sufficiently important thing to kind of talk to you about today about it as well. Hopefully we covered also some of the design patterns that we actually will try to utilize in our own case for how we are going to improve the experience for Map SDK users. And again, based on the initial feedback, we're going in the right direction. And just in the final sections, we kind of went over some of the special considerations that you really need to have when dealing with maintaining libraries. So with that, thank you so much.
Thank you, Dragan. Are there any questions? So the library you have shown us seems very comprehensive and well built. And I was just wondering how much time and how many people were working on it to create a viable minimal product that was used?
Yes, so it was a lot of different people over a pretty decently big period of time. So this is basically like a few years of work by several people. Several people. That means half a dozen or so. Again, this didn't evolve in kind of siloed way. Actually, as we were developing Studio, much of the code base has been shared with the SDK, and that was also like with the purpose of making the iterations as fast as possible and not really having to make everything from scratch. So there is a lot of code reuse, and that is what really enables us to get the libraries such as SDK to offer you full feature set of the Studio, which is an incredibly complicated library on its own. It did take a lot of effort, especially on the Python bindings. Those had to be developed from scratch. But again, like something maybe half a dozen over, say, like 4 years or so. Again, very rough estimate. There is, I do still think that there is room to improve. We aren't doing a perfect job there, but considering all the limitations and the size of the team, I think it's like a decent job for now.
Okay, thanks.
Thank you.
Hi. Did you consider creating a tool that will automate the migration between the versions, especially for like trivial API changes? Yeah, like a script that will go through the customer's code base and change the APIs that were changed in the...
Yes, so thankfully we didn't introduce many breaking changes. So any kind of code generators, code modifiers, we didn't really have to consider those very often. And we actually fairly recently deprecated a 0 point something version of the library, and we are now at 1 point something, which so far never introduced breaking changes. And actually all these API audits that we are doing are also with the goal of how can we just expand our API and then at some later point really make a sudden and big breaking change, but again to try to minimize the risk for our customers. We again don't want them to be doing migrations very often. Even with code mods, we just want them to have a stable experience overall. And again, keeping it at the same major version is basically like proving that. So like we didn't have real needs to consider something like that, but we did consider it.
Hi, thank you for the presentation. So my question, as a person who kind of maintains an internal library at the company that I work at, you mentioned that you need to support a lot of different platforms, like you mentioned the Shell platform, Visual Studio Code, things like that. My question is, how do you know that you didn't, let's say, break the intuitiveness of the API that you're making? Because sometimes we add something to our library and we realize that like using something, it's kind of strange. We need to kind of read like the source code to figure it out. So how do you test this? Like, do you dog food it? Like, how much time do you use like a like an alpha version of the library internally in your, like, how do you do it?
We do have internal teams that are testing our different SDKs. So Map SDK is just one of them. We have a couple of SDKs, and Ranchin actually talked about Movements SDK as well. So we do dog food our own things that we are making. But actually, I think we put the biggest emphasis on the API audit. So we really try to catch things ahead of time. Because, again, our team is very limited. And like we have limited amount of resources to work on it. We try to really have a very strong foresight in how things can go wrong. And I'm trying to now understand like why we were sufficiently successful in that regard that we didn't really have any reasons to introduce breaking changes or to really deprecate any parts of the API. But we simply do put a lot of effort and a lot of time into API audits. And again, this is also like a lot of internal talk with people that have also spent years working on open source libraries. As I mentioned, like we do have a lot of people that are maintaining these visualization open source libraries, and all that experience in knowing how to develop externally facing libraries, how to properly do audits for them comes very in handy when you're also like making something else as well.